types. A key part of programs are types. Basically, when you want to do anything specifically, you need to define your own types. Data structures require types. You need to be able to say, okay, these things belong together. It is very helpful to also be able to check on a particular type, but you need to say, okay, I want to have something that has these values together, or this is a number, this is a true or false value, a boolean, string, etc. It helps you to understand what is going on and make things work the way you expect them to. And whatever language you use, every value has a type. And in certain cases, you can use, if you can actually figure out what the type of the value is, you can use that type to do something different depending on that type. In this case, you do something called 1 or do something called 2, depending on the type. Types can be handled by your language in two different ways. You can do it statically. So if you have all your storage locations, all your temporary locations have an assigned type, there's no need to record the type of every value because you already know the type in your compiler, so you know which function to call because you know what type something is. Of course, that requires the usage of types to be 100% correct. Another part that types can do, another way that you can handle types is dynamically. You record for every value what the type of it is, and then at runtime use that. It also often is combined with something called duck typing, where if you have data structures, rather than requiring the data structure to be of a particular type that is expected, you just delay that by saying, okay, I need to have these functions in that structure or these names of attributes inside the structure, and only when you try to get a value and it's not there, it might crash, or it might say, oh, there's no value there, I'm just giving you a null or an undefined in JavaScript, and happily continue. Happily continue is a relative notion, and it also makes it much harder to have a good confidence in the quality of your code if you have that kind of language behavior. And that's often why you want to enable strict mode, for example in JavaScript, so that it doesn't do that and you get an actual error message rather than it trying to muddle through. Another point is that if you use object orientation with polymorphism, it requires some degree of dynamic typing, but it's still a regulated version of dynamic typing. And in particular, it can still have static checks. Yes, it needs the type information to know which particular function you need of the subclass, or which particular function, each subclass might have its own implementation of it, but you still know that the value, statically that it is of the parent type. Therefore, you can actually do checks. The only way you break that is with typecasts, where you're saying, okay, I know better than the compiler. And sometimes you do because the language doesn't always allow you to express everything. But dynamic typing, so it is a checkable one because the parent class says you must have this function. And every child class will be checked, yes, that it has such a function. And one of the interesting aspects of types is the use of generics. So sometimes you want to say, I want to do something that works with any form of value inside it, but I want to have that type also still be consistent. So generics are basically the way of handling that. You can put the type you use as a parameter to your function or to your class. Or effectively, if you look at computer science, it's called something called a dependent type, but a very limited version of that if you compare it to what you can do in research languages or things like Haskell or something like that. They are much more powerful, but more complex to use. So in this case, in the left, you can see an example of what such code would look like in the case of if you do it by hand, so to speak. You have a base list that just takes anything, and the string list hides away this the fact that it actually stores anything and makes the checking work. So this is kind of how it works, but you don't really want to do that for every single type. And you need to do a lot of casts as well. So generics get rid of the casts, get rid of having to have a subclass just to make sure that the parameter types are correct, etc. It gets rid of the need to have a protected do set that is not visible for other things. And it needs to be a do set, not set, because do set, you can't override a function with a more narrow contract, because you need to be able to call the function as use the object as if it's the parent. The parent says any value can be passed in do set, and then the string list says okay, but you can only pass strings. That's not valid. Generics help you to do this. So generics effectively define a family of types rather than a single type, and the way that you have your in-out stuff like that defines how you can actually relate different types in this family.